Hello friends, I'm Ashish Darbari, founder and CEO of Aximize. And guess what? It is DAC week, and it is this time of the year in July when we have one of the most famous conferences in electronic design automation happening. Of course, this year with the COVID-19, it's going to happen virtually. And we take this opportunity to talk to all of the main formal verification vendors who are actually helping us deploy formal verification. Today in-house, we have Joe Hupcey from Mentor Graphics. He's a product manager for Questa Formal product line. Hello, Joe.
Hello, Ashish. Thank you for having me on your program here.
Oh, it's great to have you, Joe. I just thought it would be a good time to talk about what's hot with formal at Mentor. So before we get started, I just wanted to get a feel of why is your company interested in formal verification? Aren't you selling enough simulators and emulators anyways?
Certainly, we're doing a great job selling, those products, but it's been apparent for years since Mentor acquired Zero In that formal is a essential part of a complete verification flow. And it's always been Mentor's goal, and certainly Siemens' goal overall, to provide integrated tools and methodologies to help customers, create and verify their designs, whether it's, just focusing on a specific IC or IP, integrated circuit or an IP, or, a whole system. So having formal is essential to complement simulation and to complement hardware-assisted verification. And other elements as well. They each have their own strengths, and when you interlock those strengths together, that's where you get an effective end-to-end verification flow.
So you mentioned Zero In, right, Joe? So you guys originally formal verification, especially from property checking point of view, if I'm not wrong, came from Zero In. That was acquired by Mentor, and then you guys got bought by Siemens a few years ago. So tell me a bit about how formal is helping up shape the internal business activity within Siemens, and what does Siemens think of formal verification?
I just see the macro level trend that it's pretty clear to me that Siemens, like I said earlier, they want to provide a complete flow to their customers. And when you look at the breadth of offerings that the group that we're in digital industries, it's fantastic. When you say the word simulator, in fact, in some cases that can apply to software that models somebody working on a factory floor, and so that they are able to safely, attach something to, something that's moving by on an assembly line, and that's called simulation, right? They have a whole workstation simulator. So it's very overloaded. Anyway, the point of the story is Siemens wants to provide, a complete solution for customers. And by complete, I mean really complete, going into the mechanical realm, going into those realms as well. And so Mentor is, clearly a key part of that, is in a deep dive in the electrical, domain, right? In electrical oriented domain versus mechanical, like the NX product lines and that sort of thing. And, again, as I said earlier, it was clear to Mentor many years ago, before I joined Mentor, that formal is a key part of verification, and that's why they acquired Zero In. And to this day, I would say 90% of the Zero In team is still with Mentor.
Wow, that's impressive.
We're thriving in that environment. Yes, it's one of those things that kind of, because the branding changed from Zero In to the Questa branding, it can be easy for people to wonder, well, what happened to the Zero In guys if they're used to hearing that one name? But the reality is we're doing great. And it's part of a complete flow where the strength of formal, as you well know, is that exhaustive mathematical analysis. And for all sorts of different design styles and technologies,
sure,
that formal is the best tool for the job. And of course, that fits into or dovetails next to how simulation can be the best tool for the job for certain activities and verification. Same with hardware-assisted verification.
Sure. What are the problems that you are solving with formal verification for your customers? What kind of problems are they coming to you with?
There's a really interesting variety of problems that we get. I would say, let me start with the most popular case that comes in, and it has to do with something that's conceptually very simple: connectivity checking.
Mm-hmm.
You would think, oh, all you have to do is just sit down and, or maybe just script up some clever, correct by construction scheme where you make sure not just the point A to point B connections, but the multiplex connections when you're bringing in, low power and BIST and that sort of thing. You think, oh, if somebody's really organized, they could pull that off. Well, it turns out the complexity of that problem has just exploded. Even just on a pad ring, let alone the rest of the circuitry,
Mm-hmm.
you can have 200,000 connections. That's a pretty common number that comes up.
Right.
And doing this is a great example of where Formal shines, because doing this with a test bench-based approach can take just weeks to develop the test bench and then a lot of runtime to perform the actual analysis. Whereas the formal application setup for this, once you just take the spec as an input, it's very quick to set up within a few hours.
Yep.
And then you kind of set it up in a regression mode. And I have rarely seen a connectivity check run take more than a half a day, even for the largest SoC somebody threw at it.
Mm-hmm.
So this is a case where, pad ring, static, and conditional connectivity, conceptually simple, actually has become quite complex, but Formal is the right tool for the job. It fits that perfectly.
What about some of the other problems that I keep hearing, especially from some of our mutual customers around property checking and CDC? What do you think is the trend that you are observing from your side?
One of the trends we're seeing in property checking is the need for an exhaustive deadlock analysis.
I see.
And as you know, trying to find out, if there's going to be a deadlock or a live lock, trying to do that in simulation or even with a lot of creative tests and hardware-assisted verification, you're shooting in the dark. You get lucky if you find the deadlock or not.
Yeah.
And too often what happens is it's found in the field. Why is this chip, every other day it sort of freezes or something. And it's a post-silicon problem, which of course is a huge problem. That's an area where property checking can really address this challenge. And this is where the innovation comes in under the hood, is because you can take the deadlock analysis, and in our case, what we've been able to do is map this into SVA constructs. So users can very easily describe the analysis that they're going to do for the deadlock, or point it at the right logic that they're really concerned about, and then let the tool do the work.
Are you saying it's like a semi...
We have a paper at DAC.
Sorry, I was just going to ask you, are you saying it's like a semi-automatic app that you guys have now for deadlock?
There's two flavors of it. There is an embedded in our AutoCheck application, which is completely automated. It will look through all the finite state machines and make sure there's no deadlock amongst them. So it automatically detects the finite state machines and then checks for deadlock. And then with the property checking tool, PropCheck, you can do that analysis plus just point, a property at arbitrary, logic, some area of circuitry that you're concerned about deadlock occurring, and run that analysis. When we're talking about DAC, there's a paper on this.
Oh, I see. Okay.
On exactly this flow.
Oh, wow. Okay.
On the Monday, it's the Monday afternoon. It's in that formal session. And it's a joint paper with ARM and my colleagues.
I see.
Addressing exactly this challenge, and they describe how they use this capability.
So Joe, one question that keeps coming up to my mind, and I'm sure our listeners would have that too. How are your solutions differentiated in the market with respect to the other players? Why should anyone give your tools a try?
Well, I can summarize it in three succinct reasons: performance, performance, and performance.
Okay.
And what I mean by that, there's three aspects of performance if you separate it out. The first one that immediately comes to mind is wall clock performance on compile time, on just the runtime of the analysis itself. And then the other element that's important for Formal is solvability. And customers are continually telling us that we're able to solve more properties we have more solutions that come in within the given, timeout period than our competitors. So it's performance in that aspect. The other aspect that's becoming more important now that customers are using more either on-premises or external grids is memory usage.
I see.
And it's kind of companion disk storage, but memory becomes the key thing. And the trick here is, or the issue here is that customers, they're given end user gets to send a job to a large grid, and it's a lot easier to get a compute instance that has the lowest memory requirement possible, right? So it's only the, 4 gigabyte, 8 gigabyte instance versus some of the large instances that you have to queue up for because all the other jobs are kind of waiting for that bigger machine. We can slip into the smaller machines and complete our runs in significantly less memory usage. So people hop on the grid right away with prop check in our formal apps in a way that apparently our competitors don't. Because again, customers are telling us, hey, these things just jump right on the grid and you come back with answers. And thus there's this kind of throughput. So not only were you running fast when you were on a grid instance, but you got a grid instance quickly, and now you've given me a result. You're back to it.
This is fascinating.
That brings us to the third thing.
Yeah, this is fascinating, Joe. Yeah, carry on.
The third element is the human factors of debug and setup, right? So we have flows. Our flow enables very quick setup. In some cases, you just give it the file, the input file and the task-related file, and then the tool automates the rest of it, the setup. We've seen this at property checking as well, that we're very good about identifying structures that need to be abstracted for formal. And then, of course, when you're actually debugging, there's the different text and GUI-based reports that enable users to rapidly root cause the issues that the tool discovered. So performance, and all those.
So you've given me a very nice summary of why you think your tools are differentiated in the market with respect to different aspects of performance, whether it's compilers or solvers or issuing jobs on the grid or setting up the tool to run. If the solution is so good and it's differentiated, why are we then seeing blockers in formal adoption in the industry generally? In your view, what are the biggest hurdles you are noticing for formal adoption, and how are they being overcome by Mentor Graphics?
Yeah, the biggest hurdles is this fear of, that, hey, formal is something that's complicated to learn. It's really challenging. I'm not sure, it's just a totally different way of thinking. I got to learn a new language, all that stuff. And, Mentor in general, the industry as a whole, right, over time has, I think, been very effectively eliminating that fear. And the first thing, and you've seen this trend in not just at Mentor, but throughout the industry, of the automated formal applications, right? Of automating as much as possible such that any engineer who knows VHDL or Verilog can adopt a given flow. And I talked about connectivity checking. There's a register check analysis. There's SLEC analysis, secure check that does can look for unintended backdoors. Those are examples of automated applications where you give it your RTL and you give it just some sort of specification file, say in the secure check case, where you say, look, here's the path that has to have absolute integrity, and is there any backdoor in it? And that's it, right? The tool does the work, and so that's made formal accessible across the industry. And this is a trend, I'm sure, as you've noticed, for the last 10 years, Mentor and our competitors as well have been working to innovate in this area. So you get the benefits of formal through this automated app, but you don't actually have to learn formal. So that's one aspect of it. The other aspect then, and what I've seen as a consistent trend, is once customers see that, hey, this formal stuff really works, because it does, as we talked about, connectivity check is one example earlier of how just drastically better the results are, and they come much faster than another approach, a simulation-based approach, is we've made property checking itself easier. Right, and there's a whole series of innovations on the input side, as I talked about earlier, making things easier to set up. There's a lot of workflow things that are being done in the GUI to make it easy for the user to kind of create a formal test bench and maintain that test bench and see the effect of their constraints.
Right.
And then as they get to the debug, to logically group waveforms together that were involved in that certain test and have the others be subordinated. Little things like that make it a lot more accessible.
So the use of apps is actually making a big difference, from what I understand, from my own perspective. And I think that's what I'm hearing from you, that these are ways of making it easier to overcome the fear element. And I'm afraid it's so hard, I can't actually, don't know what Formal does. So these things are certainly helpful in addressing those issues. And I suppose training and actually working with engineers live on the projects and showing them the value are also great ways of overcoming the the ghost, the fear.
Absolutely. The property checking itself, and I don't mean to say, it's, just stick to the apps because property checking is hard. It's been my observation that UVM is much harder to learn than Formal.
Yeah,
and I'm certain you see this in your practice. And indeed, you're an exemplar of this, where I've seen customers come out of your training courses and they are ready to go, right? Your courses are very effective in showing customers, look, it's not that hard. Here's some basics to get you started, and here's some follow-on techniques once you've mastered the basics. And you do a great job in progressing customers very rapidly up that learning curve.
Yeah, we're certainly trying that.
The same effect. By the end of that week or the training course, I've noticed this, they really are effective. And they kind of surprise themselves, right? Hey, that learning curve wasn't such a steep curve after all.
Yeah. I suppose we have to overcome the entire gamut of application space. Hey, let me get to you with another interesting question tailing on this one. So formal verification, is often perceived as a costly investment. Formal tools cost you a lot of money. What are your thoughts on this, and how can you as an EDA vendor make it easier for companies tight on budget to adopt your tool?
Sure. It's all about, like any other EDA tool, any other flow, showing, demonstrating the return on investment.
Right.
And that's the great thing about Formal, is it generates a lot of returns, of high value returns, right?
Yeah.
And, we've seen this again and again throughout both our careers, right? Where the Formal tool finds this bug that was in a fielded IP even, right? That the customer is like, oh, this has been out in the field for 5 years. And then you found this bug, and, they kind of think back and realize, oh, this is why this thing deadlocks every month and a half or so, or it has to be rebooted.
Sure.
Because Formal found this incredibly deep bug that they did not find with any other method, and so on, right? Formal is replete with examples of how it can find these really deep state-space bugs that are just showstoppers, right? And they were missed by other methods, right? So if you have a high cost of failure, and what customer doesn't, right? Customers don't want to, they want to make sure their end customers are successful and get a high quality product. And that's where Formal comes in, is to fill those gaps of being able to come and examine the deep state space issues that are lurking there. So
I suppose the
problem is, to answer the question, it generates results, and those results are high value to justify the investment.
So I suppose if somebody really wanted to give it a go with Mentor's tools, you're saying you guys can do something to make it easier for them to get started. It's not the case that there is an upward investment of a huge sum of money, which a lot of companies are saying, look, over and above the cost of the simulators, we can't actually afford investing in Formal, so they're not even able to try it out. So I suppose that's something that Mentor could help with, I suppose.
Absolutely. And there's the two levels we've kind of spoke of. There's the automated applications, which you can purchase off the shelf and hand it to any engineer who knows VHDL or Verilog. And your friendly local AE can show you how to set up the tool, get it running, and they generate results, and they generate them quickly, again, with a very minimal learning curve. And the results come back, and that usually gets customers excited about the power of Formal. So again, the I is low, the R is high from that. And then take it to the next level, where you can use property checking to really kind of create a Formal test bench and examine those problem areas of logic. And that's where there's a little more investment, but not a lot, honestly. And typically what customers do is they start, either they hire a formal expert, so to speak, or you can train one. And that's where you come in. And I've seen this again and again very effectively, right? To bring someone up to speed who's willing to learn, they have an open mind, and within a week, you get them productive, very productive with property checking, with creating a formal test bench, with debugging the results, with looking for areas, how to search for areas, or what the intuition. What's neat about your training is you can give them the intuition of where to they should start. So they're not just looking at a blank piece of paper. It's like, no, go to these areas of the circuit because those are typically where bugs like to hide. And so that's where, again, your coursework and your knowledge is so well imparted on the students. It's not a big investment. That's one person and a couple seats of property checking so they can run some things in parallel. And that's a great way to start.
So this is a great summary, Joe. So what I'm hearing from you is, as much as this is a perception that there's a high cost of investment, if you can manage it properly through a combination of great apps, property checking tools, assisted by training, the I, as you said, is a lot lower than the size of the R's. So I think that nicely wraps up my chat with you today. I'm pretty sure our listeners are listening to this and thinking, why are we not doing enough formal? Let's take a look at the tools and methodology. So thank you very much for your time today, Joe. I appreciate you're a very busy person, but you took time to come and talk to us. Thank you very much.
Thank you for having me.
So friends, I hope you liked our chat today with Joe Hupcey. Do send us your questions at info@aximize.com. Subscribe to our YouTube channel and stay fit, and we will stay connected. Thank you very much.